In this video, I'm going to shrink down 10 times every 21 seconds until I'm the size of an atom. I'm going to do this for two reasons. Firstly, I can't wait to see how bizarre things get down there. And secondly, we're going to do it in a way using a bit of a memory trick so that you'll always be able to remember the scale of the microscopic world without needing to remember any numbers. We're going to make a map of our microscopic universe that will be useful because it will be hard to forget. A huge percentage of the scale of our universe is in this world of the microscopic, in something as simple as these grains of sand in the palm of my hand. But in a strange way, that world, at least to me, feels harder to see and understand than the stars so far away. So let's fix that. Let's start the clock and jump in. Okay, obviously it wouldn't be a good scale video if I didn't use a banana, so that's step one here. I'll put the numbers here, but you don't need to remember them. Micrometers, nanometers, and picometers can get confusing. Just focus on the visuals and try and remember the journey. So I'm now the size of a coin. This is actually a real US quarter, by the way. I've scanned it using a microscope and a technique called photogrammetry. So all the detail here is on an actual coin I own, and I can explore it like it's a painting or a landscape. Now that I'm the size of the edge of a coin. I'm now in the world of these grains of sand from the desert. This for me is the beginning of where things get weird. And this drop of water will need some force to get through. Hello there. This is a tardigrade or water bear. They are tough. They chomp on vegetation in water and can survive the vacuum of space. It's quite a big microorganism, but they are all so very strange. I think they're cute. Or terrifying, it depends on how big you are. This is a red blood cell. This is where the red color of our blood comes from. 25 trillion of these are flowing through you right now, and they will take about a minute to do an entire circuit of your body. They carry oxygen from our lungs and carbon dioxide back out. But they can be damaged by bacteria. This is E. coli, responsible for a lot of food poisoning. They can divide every 20 minutes and can produce a toxin that damages your intestines and red blood cells. 99% of bacteria don't hurt you, but this one does. But this bacteria needs to watch out for a virus. Usually viruses are bad, but this one is actually awesome. It's called a bacteriophage, and it kills bacteria. This one in particular kills E. coli after replicating inside it. We might need to rely on these more in the future as bacteria is evolving to resist antibiotics. But usually viruses aren't good. Like this one, it's called a circovirus, and it's the smallest type. But even things this small require blueprints to construct, which is what DNA is. Instructions like computer code on how to make and run an organism like this. You can see it coiled up, bundled inside. I just need to be a little smaller to get in there. This is DNA, a twisted double helix of molecules, providing the instructions for the organism it's in. These groups of combinations of molecules are called genes, and they can define a trait of that organism, like blue or brown eyes in humans. It's billions of molecules long when stretched out. And the things that make them up are individual molecules made of atoms. I didn't realize DNA was so small. It's literally made of individual atoms. It couldn't be any smaller. Atoms are the building blocks of all matter. Little grey spherical clouds is probably the most accurate way to show them. This is a hydrogen atom where this journey ends. There are more steps below atom, but those get super weird, so best to leave that for another time. An atom is a good end to our story. So that was a pretty crazy journey. So how does this map of the microscopic universe work? Well, you just have to remember the order. Banana, coin, edge of coin, water bear, red blood cell. Bacteria, good virus, bad virus, DNA, atom, 10. If they were just words or numbers, it would be hard to remember, but hopefully the journey is weird enough to stick. The story leads to the next one. Then if you want to know how big, say, a single bacterium is, you can just use your fingers to count. Banana, coin, edge, water bear, red blood cell, bacteria. 6 steps. Each step is 10 times smaller, so you just go down in steps of 10. So a banana is about 10 times smaller than a person, and a single bacterium is, let's see, 10, 100, 1000, 10,000, 100,000, 1 million. 1 million times smaller than a person. A bacterium is about 1/1,000,000th the size of you. Or you could start with the edge of a coin before counting the steps. So water bear, red blood cell, bacteria. 3 steps. 10, 100, 1000. So you could fit 1000 bacteria end to end across the edge of a coin. Or because a virus is 1 or 2 steps smaller still, between 10,000 and 100,000 viruses. But the key thing is, you don't need to remember any of those numbers. Just remember the journey, and then if you ever need or want to know how big something is in these realms, count the steps in 10. As long as you can remember the journey, you'll always have a really good understanding of the scale. With a bit of thinking, you can even know the numbers. So the world of the small is tiny, fascinating, and if you have the right map, memorable. But the picture here is a little incomplete. I want us all to have the best fundamental understanding of this world, and to do that, we need to understand exactly how I've been tricking you. Sort of. The last piece of the puzzle to understand this world is to talk about linear and exponential scale. So, what is that? Well, by shrinking 10 times each time, I'm changing size exponentially. That's when something gets bigger or smaller at a speed that keeps increasing. And despite what we might think, our puny human brains aren't very good at understanding that. So for instance, this is the typical way you'd see a camera moving from atom all the way up to me. You might have seen something like this before. In just a few seconds, I can show you everything. It's amazing and overwhelming and useful, but it also gives you a slightly false impression of the size of things. That's because the camera filming this is lifting off from the atom, and then it isn't staying at a constant speed like we're used to. We're used to a camera shot being attached to a helicopter or drone, hitting a maximum speed, but instead, here it's getting faster and faster without us realizing. So the camera speed is exponential, but we're used to cameras moving at linear speeds. So it's a bit deceptive. We think we're moving slower than we actually are. I know this can all sound a bit confusing, but what I'm saying is that crazy, overwhelming zoom out shot I just showed you isn't anywhere near crazy enough. So, is there a better way to see the scale? How can we get to grips with these tiny sizes without cheating? The answer is relatively easy. We repeat the shot, but this time there's no trickery. We move the camera in a way we're used to. We move it like a real drone or helicopter lifting off from the ground. So it will start here and accelerate quickly to its top speed and then stay at that speed. Let's say it's the equivalent of 45 miles per hour, but on this scale, obviously. So let's go. This should look like a drone taking off. This is now linear speed, not exponential, and this is what our brains understand much better. It will give us a sense of scale that we can inherently comprehend. And this camera will keep going up at this speed until you can see the banana and then the normal size me. You can tell very quickly that it's now slower than the first time we did this, much slower, because we're not cheating things here. But here's the thing, this shot is now going to take a long time. So long, I can't quite fit it into this video. The camera here is now moving at a speed that we understand to get from atom all the way up to human, and that means that the shot will take a little over 30 years to complete. The shot will take 30 years. That is how small atoms are. And that's what I mean when I say the world of the small is smaller than my scale suggests. So whenever you see a video where you go into the world of the atomic or out into the galaxies, even ones I make, you'll know that you're being tricked a little with the camera speed or zoom but you'll be very happy that you are. Moving the camera exponentially is the only way we can experience these things without it taking years. So it's really useful. We just have to remind ourselves sometimes that this method does not give us a perfect sense of that scale. I've always felt lost thinking about this tiny scale everywhere, all around us and within us. And it does feel so daunting trying to comprehend this immense but tiny world. But making this video has really helped me appreciate and get to grips with it. Atoms truly are tiny, but there are ways to appreciate these levels of the small and make them less overwhelming. For me, it really helps breaking them down into these 10 realms: banana, coin, edge, water bear, red blood cell, bacteria, good virus, bad virus, DNA, atom, while still reminding ourselves that even the best map isn't perfect. This might sound strange, but one of the reasons I made this video was because I read a poem once. I don't really make a habit of doing that, but the start of this poem has always stuck with me. It's by William Blake and it begins, "To see a world in a grain of sand and heaven in a wildflower. Hold infinity in the palm of your hand and eternity in an hour." We can all interpret poetry any way we'd like, but for me, it's always made me think how easy it is to take the marvel of the world we live in for granted. I've always known there's a world in a grain of sand, but there's a difference between knowing and going. So I was really excited about making this video and going on this journey into our microscopic world, and I'm really happy that the journey was something I could share. I hope I managed to get some of the wonder in here across and that you found it useful too. I'll certainly be back in the world of the small at some point in future videos because there's so much strangeness and magic here in this immense part of the universe we sometimes forget about. I'll be back amongst the stars in the next video, looking for life beyond our planet. If you did enjoy this journey, please do feel free to like, subscribe, and perhaps join my Patreon. It's just me making these videos. If you'd really like to support me making them, see behind the scenes as I make the next one, and even be immortalized as an astronaut in each video, then do please join the crew. Thank you everyone here for your support and advice as I make these videos. Here's the link to my Patreon, and it's in the description to this video too. My hope for this channel is to try and inspire and share some of the love of science and the universe that I have, partly because science and facts aren't easy to find in a world of misinformation. I can't fix that problem. I can only add just a little bit to the ledger of positivity and truth in the world. But misinformation isn't isolated to science communication. It's in our everyday life and our news, and that's a difficult problem to fix. How do you filter the overwhelming amount of information out there? How do you fact check every headline or find how politically biased a news source is? That takes time, and who has that? Well, this video has been sponsored by a company trying to fix this very problem and make something really helpful in the process. Ground News was co-founded by a NASA engineer, so it's unsurprisingly rather clever. They're not a news company. They collect your usual worldwide unedited news, but they show you more than one side of each story. I can follow my favorite topics like space and science, and in each story, they use simple graphics to show you each source's political lean, how credible they are, and who owns those news channels. You get the same news you usually do, but you get some extra important data with it, saving you time and helping to show you whether you might be being misled or how other people might be. If understanding what's really happening in the world is important to you, you can subscribe with my link here at ground.news/epic or scan the QR code if you're on a computer to get 40% off the Vantage subscription for unlimited access this month. Otherwise, thank you everyone. I had such an outpouring of support on my last video about the scale of black holes that I was a bit overwhelmed. I couldn't be more thankful to how kind you've all been. I hope to see you again for another Epic Spaceman video. Cheers.